Just it says we're streaming. I just want to double check. So I think hold on. All right, I believe we are live. Hey everybody, today's topic on IAEI News Live is on NEC 2020 key code changes. I got Keith Lofland waiting in the background, and it all starts now. All right. Whoop. And I got to put that away. And there you are. How's it going, Keith?
Hello, Tom. Good to be with you.
It's good to be here too. We are
we saw each other last week at the IAEI Western Section meeting in Michigan. I hope everybody out there has had an opportunity to attend one of the IAEI section meetings.
Yeah.
We've got one more left. One more opportunity.
That's right.
The Southern Section meeting coming up in a couple of weeks. And so I hope to see everybody in Asheville, North Carolina.
Yeah, Asheville, North Carolina. That's going to be a great one. I know. I know the. Where were we? We were in Michigan.
We were in right around Traverse City.
Yeah, that was a good one too. And the Eastern section. So I had. I think I saw you. Did I see you or Jody?
Joseph was at the Eastern section.
Yes, and Mr. Wages did a great job there, and I was there for one day, so that was a lot of fun.
I got to attend the Northwest combination of the Northwest Southwest section meeting in Reno, and we had a great time there as well. Had a very informative educational session, and there was a world-renowned barbecue rib cook-off going on right outside the hotel at the same time. So you never know what perks you're going to get when you attend an IAEI meeting.
That is exactly right. It's amazing. You know what's really cool is, especially that one out there. It's in a beautiful area. You got great weather typically, and it's just you can't go wrong. So, and that was a combination of Northwest and Southwest, right?
Yeah. They combined their meeting. Of course, this was the first round of live IAEI section meetings we've had since the pandemic, and so they just combined their efforts. I think they're going to do that again next year as well in Spokane. They'll have a combination Northwest Southwestern meeting, which again I think will be a great event.
Oh, absolutely. So today's topic is NEC 2020, and I know you did. You talked a little bit about this, or a lot about this, up at the Western section. There were some key changes in the 2020 code cycle that I think, to your point, we were talking about doing some things around 2023, but the 2020 changes, especially around services and some ground fault changes, really, I think, had a significant impact on the electrical industry from a safety perspective, obviously, but also just from how you lay out a project or do a design.
Right. You know, and I said this at the Western section and the Northwest Southwest section meeting as well. You know, sometimes I get asked, is there a theme to this year's or this code cycle? And sometimes you can see a theme kind of running through some changes, you know, reconditioned equipment and things like that. This year, for some reason, and it was not intentional, it wasn't something that, you know, the code panels got together and said, hey, we're going to make all these changes together. But there were a lot of significant changes to the residential setting this code cycle. I mean, really impactful changes that are going to really have a dramatic impact on the way we move forward with residential construction. And we're going to look at a few of those today. You know, the emergency disconnect, outdoor emergency disconnect, things like that, that really are going to have an impact when a jurisdiction adopts the 2020 code.
Yep, I got my thinking pen. So
all right,
let's get this ball in gear. So what do you want to talk about first? This is your time.
go to 210.8A. If anybody's following along in the analysis book, that would be on page 57.
210.8A. I'm looking at here we go. There we go. I got it. 210.8. All right, so let's do this. Boom. And we got Michael Hofkin. We got to be careful. We got to be careful, Keefe. We got Michael Hofkin on the phone, so online. We got to watch.
That's a pretty good change there, but go a few more. I was wanting to get to the the voltage. Yeah, right there. Go back one.
There we go.
And before we get started on that, you know, you and I had talked a little bit before we started here. For those that may be tuned in that don't know how a change gets made in the code, it all starts with somebody submitting a public input. And the beauty of the National Electrical Code is that it's an open consensus process. In other words, anybody can make a change to the code. But it all starts with that public input. You know, a lot of times when I'm doing a class, particularly in person, somebody will raise their hand and say, hey, I think the code needs to say this or the code needs to say that. And my response always to that is, well, I can't wait to see your public input, because that's the only way a change is going to get made. And so, and there's a process. You can go to NFPA's website, and there's a link and a process to where you can actually submit a public input when the public inputs are open. And so, you know, you make a public input, and your public input is going to go before one of the 18 code making panels, whoever has purview over that particular section of the code. And the code panels have to take an action on every single public input, resolve it, which would be rejected or accepted in part, things like that. And then once that change, let's say the code panel acts favorably upon your particular public input, that change will show up in what's called the first draft of the National Electrical Code. And then everybody has the opportunity to make a comment on that particular proposed change in that first draft edition. And then the code panels get back together and go over those comments. And we have to take an action on every single comment as well. And by the way, I serve as chair of Code Making Panel 7, and Tom serves on Code Making Panel 2, which has purview over 210, which we're getting ready to look at here, and things like that. And so that's kind of a real quick synopsis of how something gets changed into the code. And it all starts with you making a public input.
You know, Keith, I tell everybody that when we go to like section meetings, like you say, you're doing an educational program and people say, I don't like this portion. I tell them, take your book, grab your Keefe pen, and sit down and make some notations inside your book, because here's what happens. We always do this, or at least I do this. I think about a really good change, and if I don't write it down, I completely forget about it. And then when you're going through the next cycle, you go, oh yeah, I forgot, because you don't want to miss the public input phase, because then it becomes new material in public comment phase, and you may not be able to get your change. So make your comments in your book as you go, use the stickies, and then you can go, like you said, go online and make your public input. So
the first change that we'll look at here was a pretty dramatic change. And again, it's one of those changes that is going to have a dramatic impact on residential construction. And historically, when it comes to GFCI protection at a dwelling unit, and of course that's covered at 210.8 paren A, 210.8B is for other than dwelling units. This one was a change at 210.8A. And historically, we've always been kind of limited in our GFCI protection to 125 volt, 15 or 20 ampere rated receptacle outlets, where, you know, in certain areas, there's like 11 areas that are listed under 210.8A. And, like I said, in the past, we were limited to 125 volt, 15 or 20 ampere. Well, look at the change in that first bullet point there. We went to 125 volt through 250 volt receptacle outlets. And notice that there's not an amperage rating right there, which was interesting. So very significant change. And if you go to the next slide, Tom, what does that mean for you? And there you go. Something like a dryer receptacle is now going to require GFCI protection, whereas in the past didn't. And it was kind of funny, especially if I was doing a class with some electricians, maybe some apprentices that didn't have an extensive background in the code. We'd start talking about GFCI protection, and I would say, that receptacle right there by that washer box, that 125 volt receptacle needs GFCI protection. And one of the apprentices would always raise their hand and say, well, what about that dryer receptacle a foot away from it?
Yeah.
And well, nobody has submitted enough public. Yeah. But really the shock hazard is the same right there. And if I recall, you guys on panel 2 received some substantiation about some injuries and deaths that had occurred with that dry receptacle as well, right?
Yeah, and you know what? This is a good point to bring up, because right now in the 2023 cycle, so think about this. That receptacle, is the hazard the receptacle? And the discussion we're having on panel 2 right now is the hazard the receptacle? What drove the requirement for GFCI protection here was not because somebody touched the receptacle and got killed. It's because the cord or the appliance that was plugged into it.
Yeah.
Exactly. Now, the other change that just think about that principle, that it's not the receptacle, it is actually what's plugged into the receptacle. And why do we pick the receptacle? Why do we do all the measurements off the receptacles? Because they're there whenever you're doing rough-in inspections. They are there to make life a little easier for inspectors to be able to measure things, right? Now, what we're learning, what we're talking about in the 2023 cycle is when you start thinking about the distance of a receptacle from, say, a sink. Now we're saying, look, what's driving these GFCI requirements is really the appliance. And if my receptacle is not within six foot of the sink, but that big metal box that has water and it's tied to electricity and it has been shown to kill people when it fails, and that's what drove all of these other requirements, why don't we key it off of the location of those fixed appliances? So that's the debate that we're having right now in panel 2. And that'll be interesting to see how that all fares out.
For the 2023 code.
Yes.
Right? Yeah. And that's a good point, Tom, because, when it comes to GFCI protection, I say this all the time. It's like real estate. It's all about, my phone's going off here. Sorry.
That's $20. That's $20, Keith.
It's all about location. Yeah. So in other words, somebody's going to call and say, hey, Keith, I heard you talk about it. Somewhere in the code, it said something about the dryer having to be GFCI protected. Well, it's not. The code doesn't say that. The code says, the receptacle is what we're currently keying off of. But yet, like you said, I think there is, or you're indicating that there is some discussion amongst panel 2 that maybe it's time to go to the appliance rather than the receptacle. So we'll see where that goes.
That presents a lot of challenges for the inspector, in my opinion.
It does.
But it's something that we have to have. We have to have that debate and see where it goes. That's all there's to it. Yep.
Let's go look at a change in 680, if you would. Go to that part 2.
Yeah, we can do that. Hold on. Let's do this.
And go to 680.2 or 680.50. I think it's located at 680.2.
680.2. So let's do this.
It's the.
All right. So. Whoops. Sorry about that. 680.2. You know what I could do is I'll just, there it is. 680.21, 680.9. Oh boy,
It's
680.2.
the splash pad, so it may
Yeah.
go back, or
Oh, oh,
I'm
no.
not sure which direction it is, Tom.
Yeah, that's okay. I'll find it. It's right here, 680.2. So all
It's
of
for the
these,
splash pads. Yeah,
yeah.
yeah. And we had some requirements come into the code for the 2020 code for splash pads. So that means that beginning in 2020, splash pads were new, right? Well,
Yeah,
no. I mean, we had been seeing these things for a decade or so.
absolutely.
We just didn't know how to treat them. And so finally, for the 2020 code, first thing we got is a definition of a splash pad, what it is. And then we had a requirement show up at 680.50 in the fountains section of 680 to tell us how to treat a splash pad. And of course, you see the definition of a splash pad there in the second bullet point, a fountain with a pool depth of 1 inch or less,
Oh,
intended for recreational use by pedestrians. And right now in the aquatic world, that splash pads are probably the most popular form of recreation that there is. And I think they're popular, especially with the parents, because you can take the little ones, the 2 and under, to these splash pads, and they can enjoy them, and you don't have to necessarily worry as much. You always have to worry, but about falling in a pool and in 3, 4, 5 foot of water, and a possible drowning. And I think that's what kind of makes these splash pads so popular. But um, the key change right here is in that third bullet point right there. And at 680.50, it tells us that we're going to have to comply with Part 2 of Article 250. 680.
oh,
So what's Part 2 of Article 680? Well, that's a permanently installed pool. In other words, you're going to treat a splash pad just like you would a permanently installed pool. And so what else do we find in Part 2? Well, 680.26, for one, our equal potential bonding grid. The hazards that would be involved in a permanently installed pool, in other words, the necessity to ensure that I have proper bonding on all my metal parts, especially those metal parts within 5 feet of the pool and all. You want to, we run an equal potential bonding grid, and bond all those parts together so that they're at the same voltage potential. In other words, if I were to reach out and touch a ladder and then reach out and touch a diving board or something metal, I want those already mechanically, electrically joined together, so they're at the same voltage potential, so my body won't serve as the conducting object between two pieces of metal that are at different voltage potentials. Because you know as well as I do that if you provide a path between two
mm-hmm.
conducting objects at different voltage potentials, the voltage is going to equal itself out between those two, and you're not going to enjoy that. That's
Absolutely
your
not.
body, and then we get into the let go thresholds and all. And if you're above a certain amount of current, 5, 6, 7, 8, 12 milliamps of current, then you're probably in a lot of trouble there. And those shock hazards are the same around a splash pad as they would be a permanently installed pool. And so I think most installers and inspectors were migrating to Part 2 to begin with,
Mm-hmm.
when they were enforcing the 14 code or 17 code or something. But now they have something to actually hang their hat on and require people to go to establish an equal potential bonding grid around the pool, a splash pad. I think there's a couple of photos
Yeah.
to show what we're talking about there. That's
Yeah.
And these have become very, very popular, around the whole country.
Yeah. Yeah, these are and when you look at 680 in part 2, there's a lot of things in here about all the different luminaires, because I know there are lights in here as well, especially in the ground. So you'll have all of those requirements. Now, here's another key thing. When you brought up the definition, I went to Article 100, but it's not in Article 100.
It's not in 100.
It's in 680, but on the 2023 cycle, all those definitions are going to be located in one location in Article 100.
Yeah. I think we're going to end up with, I think I heard the other day, 840 definitions in Article 100, which is going to really take some getting used to by us old gray heads. But, it's a good thing. I think it'll all work out in the end.
Yeah, I think, like you said.
This picture right here, I think you can kind of see a fence or a railing in the background there. We took my granddaughter to a splash pad. That one looks like it's wood, but we took my granddaughter to a splash pad not too long ago, and it had a metal railing all the way around the splash pad. And my granddaughter, I even got a picture of it. My granddaughter jumped up, and on the bench, and then was all over that railing. I was standing behind the railing, and yeah, I mean, do I want to? Was I hoping against hope? That railing was all bonded together with all the other metal parts associated with something like the splash pad here, and absolutely. So.
Yep, and all of these look like all of these little displays. These are all metal, and I'm not seeing, but I know there's got to be lights in and around here. Because I've seen a lot of these at night. They light up.
Yeah, there's typically have lights in the floor, if you will, in the concrete there that shine up. And just like that, the tree there, the green poles there.
Yep.
Those are easily within reach of each other. Those a couple of those poles right there, and so absolutely, I want to make sure that those are mechanically, electrically joined together, connected together, to be at the same voltage potential before me or my granddaughter reach and touch those, for sure.
Absolutely.
Yeah.
Absolutely.
All
right.
Let's go back to part 1 there. And let's go to 230.71B.
230. Oh.
And that's on page 126 of the analysis book, if anybody's following along.
230.71B.
B as in boy.
There we go. Here we go.
And what we have here is one of the fixtures of the National Electrical Code. There's code requirements that kind of stand the test of time, and are they're kind of the pillars of the NEC, and this may be one of them here. And this is
Keith,
talks about sir.
Before we go on, we got a couple questions or one comment from Michael Hofkin. He says that there are PIs for the 2023 NEC to address bonding at splash pads. So they might be doing something a little special there in 680. But Barry Yeslow asks, how can the outside edge of the splash pad be determined for the equal potential bonding, which is an interesting point. What is the outside edge of a splash pad?
And the answer to that is yes. If I'm first of all, who's going to determine that?
Yeah.
The authority having jurisdiction. And if I'm your AHJ, it's going to be the furthest point possible that of any metal, in and around that area. With a permanently installed pool, it's fairly good, well defined with the belly steel or the deck steel, and the code even says 3 foot out from that.
But you know what? In a splash pad, if you look at the definition says a fountain with a pool depth of 1 inch or less, intended for recreational use by pedestrians. So I would argue that whatever my area is, wherever I can't get a 1 inch or less pooling of water
Yeah.
due to my splash pad, that would be the outer edge. And it may be because I've seen some of these, like I was in Philadelphia and they have a nice big area there. We have all this. Now it is very distinct where you can see there's a lip, right? But like in the ones that we just looked at, it looked like a flat piece of concrete that goes out, but you can see what gets wet and what doesn't when the event's going on. So
the one we took my granddaughter to, you know, that had the metal railing around it, the concrete kind of followed that metal railing, or the metal railing kind of followed the concrete there. And so it was pretty well defined right there,
right,
as well. And I suspect we'll end up with something similar to what we have in 68026, with the 3 foot out from there,
right.
would constitute, you know, your equal potential bonding grid. And you know, gosh, we have changes like this all the time, don't we? Where we get something in the code as a starting point, and then it takes us 1-2 code cycles after that to kind of dial it in, and get all of those things that the 22 guys sitting around a table just didn't think of. And
well, you know, and Michael brings up another one. The moment you get above 1 inch, right? So at 2 inches, it's now a swimming pool. So you know, you could make an argument. Don't let that plug get the drain get plugged, because then you'll go above that 1 inch and now you're a swim. But in reality, think about it. What did they do? They went straight to part 2, which is permanently installed pools. So in reality, whether you're treating it as a splash pad, or if you're saying, well, you know, to Michael's point, hey, at 2 inches, you're into a swimming pool. The requirements for swimming pools, permanently installed swimming pools, are the ones that you're following, because you've got the lighting in there, the bonding, to your point. So in reality, you're treating it like a swimming pool, even though it's less than 1 inch.
And I just use 68026 as an example of what you would have to comply with. At 680.50, it tells us that we got to comply with all of part 2 for a splash pad. So, you know, all of those requirements that we just talked about the 3 foot out and so on, that's in play right now, because I have to comply with all of part 2.
Yep.
For that splash pad.
Now, Robert from Omaha says, "Who is measuring?" And here's what I've learned, Keith. How do you know you're going to be an electrical inspector? When you're born, when you come out, you have a Milwaukee ruler in your right hand. Okay, because every inspector carries a measuring stick.
Yeah, yeah. All of that's going to, just like other places in the code, all of that, any gray areas are going to be determined by the authority having jurisdiction.
Yep.
Sure.
All right.
Good questions.
Good questions. 23071.
Yeah, this is one of those pillars of the NEC that you don't see a lot of change in from code cycle to code cycle, but we actually had a change here for the 2020 code, and this deals with the number of disconnects, service disconnects we can have. And of course, you know, the code tells us we can have up to 6 means of disconnect, 6 throws of the hand, you hear a lot of times. And what changed here is you can still have up to 6 means of disconnect, but when you get to the 2020 code, in the 17 code, 14 code, 11, and so on, we had a choice here. We could have those 2 to 6 means of disconnect in one enclosure, or we could have them in 6 separate enclosures.
Yep.
And what changed here for the 2020 code was the elimination of those 2 to 6 disconnecting means being located in one single enclosure. Go to the next slide, if you would, Tom. One more.
Whoop. Oh, yeah.
And then one more, it'll show knock that out. Yeah. So, again, you can still have up to 6 means of disconnect like you see on the right over there, but you're no longer allowed to have them in one enclosure. And a lot of what drove this was the barrier requirement. If you'll recall, in the 17 code, we had the barrier requirement come in for panel boards. It was already there for switchgear and switchboards, but the word panel board was added in 408.3C, I believe, somewhere in there.
Yep.
Now that's been moved for the 20 code. If you're looking for that barrier requirement, it's no longer in 408. It's now in 230, Article 230, 62C, I think. And in other words, so the barrier requirement would apply to all service equipment, not just panel boards and switchgear and so on. It was the reason it was moved to 230. But I happen to have been a member of Code Making Panel 9 when the barrier requirement came in. And the previous code cycle, the previous 2 code cycles, we were asked to put that barrier requirement in for panel boards, and it was rejected for a couple of code cycles, simply because it was just going to be impossible to comply with the barrier requirement. And the barrier requirement is that what it says, we have to barrier off all live exposed parts inside of a panel board. In other words, when you take the front lid off, if it has a main in there, you can turn that main off and you don't have any live exposed parts below that. But the lugs where the two or three service entrance conductors come in, that would be your live exposed parts. And the manufacturers did a great job of coming up with a solution, and most of the manufacturers provided the little rubber boots, yellow rubber boots and things like that.
Yep.
Plastic that would fit right over those lugs. Well, especially in older panel boards where you had more than one means of disconnect, up to 6 means of disconnect, and again, remember the old split bus panel boards and things like that. It was just going to be impossible to barrier off all of those live exposed parts. And so Panel 9 had to put an exception in the code there for the barrier requirement for those existing panel boards that had more than one means of disconnect in one enclosure. And so the folks that got this change into the code, and by the way, this was labor that got this into the code. This is all about safety for the electrical worker, which is who's not for that?
Absolutely, yeah.
And so they kind of in between the 17 code and the 20 code, they went after that exception, and they actually went right here where the exception was, the conditions for the exception existed, and did away with the part of the 6 disconnect rule, which made that exception obsolete now.
Yeah.
And so when it got moved to 230, 62, the exception didn't come with it because it wasn't needed anymore. So, wow, yeah, this is one of those pillars of the code that you don't see a change a lot in these type of changes.
Absolutely.
I mean, requirements in the code. And so this was kind of jarring when you first.
Yeah. Oh, absolutely.
And you had to really bear down and read this, and understand that they didn't take away the 6 means of disconnect. It's still there, but you have to have them in separate enclosures now. Can't have them in one enclosure.
Yeah. And it's amazing, like you said, it's a rule that's been in there for ages. And if you think about when we do electrical work, I always say about this, whenever I do a 70E class, I always go back to like the early 1900s, the American Electrician's Handbook, and things that we used to do that we would never do today. And we laugh about it, right? And we say, gosh, do you believe they actually would touch conductors with their fingers and all these great things, right? But I keep looking at things like this and say, just think, 60, 80 years from today, in some 70E class, are they going to be looking back and saying, would you believe they were, they used to do this in the past and they used to work on 480 volts. They worked on exposed conductors, et cetera. You wonder, what are we doing today? And this, I think, is one of those. When you open up a panel board that has 6 disconnects in it and you're staring at bare copper or aluminum bus, the only protection you have is on the line side of the utility transformer.
Yeah.
That's insane.
Oh, this rule's older than Michael Hopkins. It's been in the code for a long shoot. So.
I don't know. That's kind of old there. So, but yeah, this is and the other one that's what do you call it? The meter centers. The ones where you have the bubbles on either side and you have that center panel that you open. That's another one in the 2023 code cycle. How we're addressing that is saying, look, you're not going to have a meter center that doesn't have a main, just like these panel boards, because you have the same exact problem there. So meter stacks are okay. They can be barriered off, but meter centers, we couldn't even change the standard to address this change.
No. And like you said, that's another one of these changes that comes into the code that's going to take a couple of code cycles to get it where we need it. And I think you will see a little bit of movement here. The basic requirement here, I think, will stay the same in the 2023, but those meter centers, like you said, had to be addressed because people were asking questions about those.
Yeah.
As soon as the ink dried in the 2020 code.
Yeah, and everybody thinks they have the solution. I know one manufacturer was like, look, I do have a compartment, but when you open the door and you look down, you're looking at the next breaker down. They were like, well, that's not a compartment. Just because you open the door and you can see a circuit breaker in this little, what you think is a compartment, doesn't mean that it's, because if you're working in there and you drop something down, it's going into the equipment below you, all that exposed bus. So, that's why the language really drove compartmentalization.
Yep. Are we ready to go?
I'm ready when you are.
Okay, let's go to 110.26C2.
110.26C2.
That's on page 46 if you're following along in your analysis book.
And I would say to remind everybody, you can go and purchase the analysis book from the IAEI's website. Great. I mean, the graphics in there, the diagrams, everything is just absolutely phenomenal. These slides are out of the PowerPoint slide deck, and you can purchase the slide deck as well. So if there's if there's an electrical contractor out there that says, hey, they want to give their an update to their own people in their organization, they can buy this and educate themselves on it. So good stuff.
This one deals with working space and in the past, when it came to large equipment, and the code talked about large equipment here at 110.26C2. And the reason that this is important, I guess, is because if you have a quote unquote piece of large equipment, then you have additional requirements that kick in. For instance, if you have a large piece of equipment, then you have to have entrance egress at both ends of the working space of that piece of equipment, or have the ability to double that working space, things like that. So what defined a large piece of equipment in previous editions of the code was that you had to have a piece of equipment that was physically 6 feet or greater, but it had to have a rating of 1200 amperes or greater. And so I know you're not going to believe this, Tom, but there were some installers that would say that to avoid the large equipment requirements, rather than put one piece of equipment rated 1200 amperes, they would simply put 2 pieces of equipment, one rated 600, the other one 600 or 600 and 800 or something like that, and avoid the large equipment requirements.
Yeah.
Well, that's not going to work when you get to the 2020 code, because a change occurred here to say that what would define a large piece of equipment now, you still have your 6 foot width requirement, but now it says 2 or more service disconnect enclosures with a combined amperage rating of 1200 amperes or greater. So the 600, 800 amp, 2 pieces of equipment that would not qualify as large equipment under the 17 code would now apply and be considered large equipment under the 2020 code. And if you go to the next slide, I think there's an illustration. Yeah. In the past, if I were to do something like this right here, that 800 and 600 amp 2 pieces of equipment, then I could avoid my large equipment requirements. Again, entrance egress at both ends of the working space, or be able to double the working space out in front of that equipment. But that's not the case, again, when we get to the 2020 code. Another change that occurred right here, you're talking about safety for electrical workers. Great change occurred right here. And that one is the red text there that says, if you have a piece of equipment and it has a door on it that opens, that door cannot impede my entrance egress in and out of that working space.
That's
right
right
there. So, where we show that door, it looks like it's, a couple of inches away from the opposite wall there. Well, that's going to be a code violation. Now you're going to have enough space with that door open between that door and that opposite wall right there to afford entrance egress out of that working space. I can remember a lot of times, even when I was working for IAEI, and I would go out and gather photos. I'd have the opportunity to right alongside a working inspector, and we would go look at we'd get into an electrical equipment room like this, and the inspector or the installer would open up the door there, and I felt completely trapped. I've been in situations that were just like what we're illustrating right here. And I thought to myself, at the time there, man, if an arc blast occurred right here, I would be in big trouble right here.
Absolutely right.
So that was a great change. I thought. And I felt completely trapped to require that door not impede on your entrance egress to and from that working space right there. So two changes actually occurred right here that were good changes. Yeah.
So Robert asks, he says, define space. It is not a room, right? With question marks. But I think the key thing here is the working space is defined in the section. It tells you how many inches of space you need in front of this equipment. Now, with the doors open like this, Keith, in your opinion, would you measure your working space from the end of the doors?
Well, this whole section, and that's kind of a misnomer that you have to fight sometimes. This whole section talks about working space. It doesn't talk about the room that contains the working space. Right. A lot of people want this section to say, in other words, like when it comes to large equipment, they'll say, we have to have an entrance egress at both ends of the room that contains the working space. Code doesn't say that at all. The code says you have to have entrance egress from the working space, and the working space is clearly well defined.
Right.
Now that might be a physical door at the, because when you get in real world, these illustrations are cute and clean and pretty, but in the real world, the builder here is not going to give you 2 inches more than he has to.
That's right.
Would I rather this space be here for electrical equipment, or would I rather that space be something that I could rent out? So they're not going to give you a whole lot of space, an extra space in an electrical equipment room. So a lot of times the entrance egress from the working space is a physical door, but that's not what the code says. The code says that I have to have entrance egress from the working space. And so if I had a room big enough, this room right here we're illustrating isn't very big at all either, but as long as I had the ability to step in and out of that orange area there, I've met code. Now,
Okay.
a little bit later, it's going to say a little bit later in the code there, it's going to tell us that any personnel doors that are within 20 feet of that working space, now they have to be provided with panic hardware, open in the direction of egress,
right.
and so on. So
yeah, because you're worried about, but like in this case here, I've got a couple issues going on here, right? Those doors are impeding my egress because of their proximity to the walls, right?
That's a code violation under the 20 code. Yes.
Yep. Now, if this bottom wall, so if my wall here, I'm just gonna I'm gonna take my pen. If this wall here was further away, my doors, I still have to have my doors open wider, don't they? I mean, I think we're addressing that in the 2023 code, because I think you have to have a minimum of 90-degree angle on those doors. But I could have the doors open, and my working space, is it just in front of the exposed, or is it at the end of the door back?
The working space would be that defined orange
in here
shaded area. Yes.
Okay. All right. So I wouldn't be measuring it from this outside of this door.
To make this code compliant, you're going to have, and hey, let's face it, I didn't have enough room on the slide, period. That's why it's not. But at the end of that door on the left over there.
Oh, the end of this one right here?
Yes.
Yep.
From right there to that wall, what does the code say? It even gives a minimum of the an exit. I think it's 24 inches, something like that.
Yeah, 20. So it says entrance to and egress from required working space not less than 24 inches wide and 6.5 foot high.
So to make that code compliant, where you have that circle right there, you would need at least 24 inches from the edge of that door to that wall to make that code compliant. Yes.
And that would be your form of egress out.
Yes.
Gotcha. And then these doors here.
And then
these doors would have to have panic hardware on them.
Yes, or fire exit hardware under the 20 code, which is even more robust than panic hardware. But yeah, if those doors are within 25 feet of the working space, they would have to be equipped with panic hardware or fire exit hardware and open in the direction egress. The last thing you want is for an arc blast to occur in something like this, where the electrician's hands are probably going to be burned. He probably can't see, and having to fiddle with a doorknob, and especially have to pull that doorknob into the area he's trying to get out of.
Yeah.
With simple, with his hip, just hit that panic hardware and get out of that space is what you want.
Yep. And Robert points out, he makes a good point that unfortunately, space in commercial buildings is very limited, and you struggle with the architect telling them, I need more room for the electrical room. But then they say, what happens to this? And I see it all the time, Keith. They say, well, you know what we'll do? We'll expand your room a little bit, but it'll also be the janitor's room where they're going to keep all of their stuff. And then they take off of the janitor, right? So that's
and we've got a requirement now at 445.9, I think it is, that prohibits the top of a transformer from being utilized as storage.
That's exactly right.
You see that too. But that's what this whole change is about, what you just described, Tom. 17 code, what we're illustrating right here is code compliant with 1 inch from the edge of that door to that wall. Under the 20 code, the architect or designer is going to have to give us more room right here to have at least 24 inches from the edge of that door to that bottom wall there to make that code compliant.
Wow.
So it was a change. And again, it's funny. The code kind of works this way. If you don't pay attention, the big change right here was the 2 or more uh,
Yeah.
pieces of equipment, and the open door there thing kind of was a last minute throw in, and if you don't pay attention, you kind of you
Oh,
can go
yes.
right past that. And
Absolutely.
that was a phenomenal change as far as I was concerned, because like I said, it's going to make this code compliant. You're going to have to give me 2 more feet
Yep.
inside of this electrical equipment room right here.
I like when I start talking about this in a class, and I'll have a bunch of engineers, right? And you mention the two doors, and you say this is going to drive you into having 2 doors, and they go, oh, you could see the impression on their face, like, man, how am I going to make this happen with my architect? And then you tell them that the open doors can't impede egress, and then they get up out of their seats like, oh my goodness, now that room, I have to throw another door in, and now I got to make it deeper. So, and unfortunately, to Robert's point, they're giving us less and less space. So at least now you have a code reason that you need more real estate inside of those rooms.
Yep.
So where's our
Good
journey
discussion.
next?
Let's go to, we don't have a whole lot of time. Let's go to 23067, which is on page 124.
23067.
We'll look at 2 changes right here, and that'll probably get us to the end here. But
oh, well, let's take a look at surge.
23067, and we will also look at 23085.
Okay.
And again, 2 changes that are going to have a dramatic impact on the way we move forward with residential construction here. This one calls for surge protection at my service at dwelling units. And it doesn't say this, but it's basically, to summarize this, it's whole house surge protection. It's what we're looking at here. It has to be, as you see in the second bullet point there, it has to be an integral part of the service equipment. Or, Tom, did you know that "or" is the largest word in the code book?
No, I did not know
biggest word
that.
in the code book. Or located immediately adjacent to the service equipment. So it can either be built into the service equipment, which a lot of the manufacturers have. I've already seen all the manufacturers of service equipment like that step up to the plate and have made, the main disconnect at a dwelling unit panel board with this surge protection built right into it. Or it could be a device that you could buy. If you go to the next slide, I think it's an illustration here.
Oh yeah, there you go. Great.
Something like that right there, because there's also some text right here at 23067 that says that this applies to a remodel or a retrofit as well. So in other words, if you went out to grandma's house that was built in the 60s and upgraded her service, you got to go back with this whole house surge protection here.
Yeah.
And so, a separate unit like this right here that just happens to be built by a fine corporation named Eaton.
I know those guys.
Yeah, and gosh, I have to say this too. At IAEI, we have some industry partners.
Yep.
One of them being Eaton, and whenever I need a photograph or something of a product like this, you guys are always just wonderful about stepping up to the plate and providing stuff like this for an illustration like this, or a photo like this for an illustration.
What's nice is when you go through these books, you'll see many different manufacturers all contributing, which really I think is another strength of the IAEI, is that it has such that organization, and you and your team have such a great vast of support from the industry that
Here's my team, by the way, my right hand and my left hand.
you and your team.
Yeah.
Yeah.
No, the education department and then the digital education department
Yes.
with Joseph Wages and his staff are very supportive. And then the publication department as well. But
Absolutely.
anyway, the new 1 and 2 family electrical systems, when we reported on this right here, I just happened to have come across a installed. I've got a great photograph in there of a it's an Eaton panel board again, and it shows a panel board with the built-in
Oh yeah,
surge
surge.
protection, and
Yep.
it's just great looking photo. I was really proud of that photo. But yeah, so we're looking at whole house surge protection.
Yep.
Class type 1 or type 2 is what would be required here, and then jump over to 23085.
Yep. And before you do that, real quick, remember there's a whole new article in the 2020 code on 242 over voltage protection.
Yes.
And that's an important, because one of the things on these devices, which I think a lot of people forget because I've seen them mounted incorrectly, this length of conductor between that circuit breaker and the actual surge device has to be as short as possible. And we call that out in 242, routing of connections. It says the conductors used to connect the SPD to the line or bus and to the ground shall not be any longer than necessary. And we tried to get some language on a maximum distance because every inch of conductor that you put in between the bus and that SPD reduces the amount of protection that it's providing. So,
Tom, if you recall, I when I originally drew this illustration, I had that external surge protection up at the top by the main up there.
Yeah.
Or I had the surge protection was where it's located in this illustration, but the breaker was up by the main up there, and you saw that illustration. I don't remember where we were at, and you came and pointed that what you're pointing out right now to me, and I redrew this illustration to
like it
just for what you were talking about there. Yeah.
Yeah, and that's an important piece to remember. Now, where else did you want to go?
23085.
Oh,
might have been the next one.
Yep.
And here we go again. Dramatic impact on the way we're going to move forward with residential construction, and this one calls for an emergency disconnect at an outdoor, readily accessible outdoor location at all dwelling units. This was brought on by the firefighting community, first responders, indicating that they were in some cases having to send their personnel into a burning building to try to find the first means disconnect. And then, of course, the argument on the other side was, well, in my jurisdiction, it doesn't matter if the disconnect's on the outside, inside, the utility company's going to turn it off at the pole, cut it at the pole. So it doesn't matter. But in the end, the people that submitted this public input, panel 10 voted favorably for this requirement. We almost got this change in the 17 code. Now, what happened, and it got defeated on the floor of the NFPA meeting where we actually do the voting. And the difference, though, in that 17 requirement was it called for your service disconnect to be located outdoors, period. And that caused a little bit of concern, which ultimately led to its defeat. And so between the 17 code and the 20 code, the same people that got this change into the code, they looked for some alternatives. And so you actually have 3 options here. A lot of people look at this and say, oh, my service disconnect has to be on the outside, and that's not necessarily true. If you go to the next slide, Tom, you've got three options here. Now, the key to this requirement, I believe, is your labeling. You could put your service disconnect on the outside and satisfy this rule. Now, what you would have to label that as is, yes, this is my service disconnect, and yes, this is also my emergency disconnect.
Yep.
But you have another option to where you could have some type of a disconnect on the outside and still have your service disconnect on the inside. And you would label that yes, this is my emergency disconnect, but it is not my service disconnect. In other words, my service disconnect is still located, over in the garage or somewhere. And then the third option right here is a meter disconnect.
Mm-hmm.
Now you got to be careful with this one, because that meter disconnect if you use it in this manner, it would have to have a fault current rating and a short circuit current rating equal to or exceeding the load of the entire dwelling. And not every service or meter disconnect would actually have that label. Some would, but so you'd have to make sure it's rated properly. But in that case, you would say, yes, this is my emergency disconnect. Yes, it is my meter disconnect, but it's not my service disconnect. Again, my service disconnect is somewhere on the inside. And I was really surprised at this one, that it didn't receive more pushback, particularly from folks like the Home Builders Association, people like that. But
they presented in support of this, and then I find out I think in some jurisdictions they're arguing to remove it.
Yeah.
Don't make sense.
Yeah. So, again, I mean, one of those phenomenal changes.
Yeah.
We ran out of time here, but we were going to look at, we now have new requirements for receptacle outlets that would serve islands and peninsulas, and we no longer take a linear measurement like we did in the past. With 12 inches one way or greater, 24 inches the other way or greater. We now are going to take that's at 21052C2. We're going to take a square footage measurement on these and determine the square footage. And for the first 9 square feet, it's going to call for a receptacle. I think panel 2, and Tom serves on panel 2, and he can talk to this. And I was in the back of the room listening to all this, and it just came to the time to where we're starting to see bigger and bigger and bigger islands and peninsulas. And had we reached the point in time to where we needed some language in place, that would require more than one receptacle on these larger islands and peninsulas. And so that's kind of the genesis of the square footage requirement. The key right here in my mind is that term fraction thereof.
Yeah.
That's the key right here, because what this is saying to you is if you have a island that measures 9 square feet or 8 square feet and 11 inches, it's going to take one receptacle. But if you had a island that measured 9 square feet plus an inch, fraction thereof, it's going to call for 2 receptacles. Yep. And the first 9 square feet and then the next 18 square feet or fraction thereof would call for an additional receptacle, the next 18 square feet, and so on. So in this illustration, it looks like we have a 4x7, 28 square foot island, which is going to call for a receptacle for the first 9, another receptacle for the next 18, and then another receptacle for the fraction thereof, the extra foot there. So it would take 3 receptacles to satisfy this requirement under the 20 code. And I know there's y'all are having some weighty discussions
Yes, we
on
are.
this for the 2023, I know as well. So
Yes, we are. And one of the discussions is around you show you put the three receptacles, two on the one side and one over in the corner. But what I keep seeing, and I get pictures because I'm on panel 2, I'll get pictures sent to me in my email of all three of those receptacles in one gang or three individual outlet boxes on one location on that island. And they'll say, what good did this requirement do? Because
what this calls for, you got to use the proper terminology, and I'm guilty of this sometimes, just saying receptacle. What this actually calls for is receptacle outlets.
Yep.
And if you go to Article 100 and see the definition of receptacle outlet, or a receptacle is, any, that's where electricity is disseminated and so on. But if you look at the definition of a receptacle outlet, it says it is two or more receptacles to provide power and so on. So
in an outlet.
So a box with a duplex receptacle is one receptacle outlet.
Right. Right.
And a lot of people are trying to look at this and say, if I put a duplex, that's two receptacles, and that's not true. It's the receptacle. If it called for receptacles, yes, but this calls for receptacle outlets.
Yeah.
And there is language here that says that the location, like you were talking about, the location can be determined by the designer or building owner. So yes, and for this 28 square foot island here, if I chose to do it, I could put 3 boxes, bam, 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 with single or duplex receptacles in them and satisfy this rule. Now, my question is, why would you do that?
Well,
why would you do that?
You know why?
Yes.
Cost and ease. I mean, literally, I was just in Austin, Texas, and I had an inspector who showed me the plans and showed me the pictures. They take, and what they're doing is they're not putting 3 boxes. They're putting one big gang box and a bunch of receptacles all in that one enclosure. And they're saying, I'm calling it a day. It meets the code. And the electrical inspector's like,
No.
the owner, the homeowner will probably be a little upset to say, why the heck did you have this here? Why didn't you put one at the other end for me? But that's what you get. And to Michael's point, a quad box, so you can have where you put 2 duplex receptacles in one enclosure, one box. That is one receptacle outlet.
That's one receptacle outlet, which this calls for.
Correct.
A receptacle outlet for the first 9 square feet, another receptacle outlet for the next 18 or fraction thereof, and so on. So you have to go look at your definitions for receptacle and receptacle outlet to get your arms around this.
And I'll tell you where panel 2 is looking at right now is we're looking at all the statistics of how many children and elderly. I did it myself, pulling crock pots and fryers off of these locations. And if you think about the location of those receptacles, they're below the countertop. Those cords are intentionally going over the end. And what we're facing now is the fact that we're seeing more and more statistics. And in fact, if you go back to when it first went in the code for that receptacle outlet, the IAEI voted against it. And their argument was that you're going to start seeing people pull things off of these islands and peninsulas and injuring themselves. And Consumer Product Safety Commission brought to the table a bunch of data. So we're seriously looking at making it optional and not a requirement. And if you do put a receptacle there, you're going to have to follow some special rules to make sure that you don't have those conductors, those cords draped over the edge.
I personally hope that panel 2 doesn't go down the road to where there's not a receptacle required at a island or peninsula. In other words, because if you don't have one out there, I promise you people are going to resort to an extension cord run from the receptacle over there by the sink on the base countertops out to that island. And I think that would create more of hazard than
And so
what we have now. But
yeah, and
we're just going to have to wait and see where it goes.
yeah, and we're having that discussion right now on panel 2 because they say when it went in, there was no statistics associated with extension cords used in those locations. And here we stand with statistics around children who are disfigured for the rest of their life because they pulled a deep fryer on top of their head.
Yeah.
You know, and it's a hard decision to make, especially from a product line perspective, you know. And you say, look, you know, these are the hard topics from a code panel perspective. When you're shown data, and you know this, I mean, you do marinas and swim, not swimming pools, but in those areas, you know, you're dealing with how many kids and whatnot die in marinas, and you've got to make some hard decisions on these code panels to say what is the right thing to do.
Absolutely.
So,
Tom, my gosh. An hour goes by like that.
I'm telling you, virtually, it goes by so fast. A lot of people say, what are we going to talk about for an hour? And you go, you know what? You would be surprised. So,
we covered like four or five changes here. And,
yeah,
you know, there wasn't really any significance to the order that we looked at.
Yeah.
I mean, I just randomly chose some changes and
we didn't coordinate at all, did we?
No, we didn't. Which probably showed to the audience, but
that's part of the cool thing about being live, you know?
Yeah. But we could have chosen others and
sure.
Hey, maybe that's a future
I don't have I got Tuesday open next week, so maybe we'll get some more 2020 discussions going.
We could just pick up where we left off here, but always enjoy doing these things with you, Tom, and you do a great job of promoting IAEI on these IAEI News Live, and we appreciate your efforts for sure.
Excellent. I want to make sure everybody out there subscribe to the YouTube channel. If you're watching this, and I know we got some comments on Facebook, if you're watching this on LinkedIn, get over to the YouTube channel, get subscribed, hit the bell so you're notified when we go live and when we post videos. And remember, membership has its value. So one of the things, and Felix brought it up early on, what I'm going to do is I'm going to reach out to the education chairs across all of the sections, and I'm going to try to find some of the best presentations that were made and hopefully bring some of those virtually so that we can get some programs going virtually. And that's going to be probably a benefit of membership of the IAEI. So please get out there, subscribe, and become a member of IAEI and enjoy all these great educational pieces. So thank you, Keith, for joining.
Thank you, Tom. Enjoyed it.
All right, brother. Take care, stay safe, and remember, please stay healthy.
Somebody told me the other day that they were happy to see me at one of the section meetings, and I said, at my age, it's better to be seen than viewed. So,
I love it. All right. Thanks, Keith. And thanks everybody out there for watching. Barry Yeslow and Michael Hofkin, Josie Wages, Earth Electric. Thanks for joining in. Take care, stay safe, and please stay healthy. See you next Tuesday at 12 o'clock Eastern, right here. Take care.
Bye-bye.
All right, that's the video is going to play, and then we're going to drop off.